Okay, geometry. Moving on to the next lesson. We got section 9-4 is known as geometry's most elegant theorem. Geometry's most elegant theorem is section 9-4. And because it is extremely, extremely small lesson, I'm going to throw section 9-5 in there, the distance formula, which is basically just one quick little formula. We'll end our lesson today going over what is the distance formula. It's closely related to the 9-4 one. Geometry's most elegant theorem, you guys have probably heard of this before, is known as the Pythagorean Theorem. And if you haven't done it in a math class already, you're going to use this in every math class moving forward. They just always are referring back to right triangles and the Pythagorean theorem. You're going to be using a lot of this down the road. So pretty much every math class moving forward that I can think of, that you're going to use it at some point. Okay, maybe AP Stats is the only one I can't think of that doesn't use it. All right, so basically, if you have a right triangle, so this is for in any right triangle, and it's got to be a right triangle, otherwise it doesn't work. In any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. All right. The sum of the squares of the legs is equal to the square of the hypotenuse. So the legs are the two sides that make up the right angle. They usually call one of those A and the other one B. It really doesn't matter which one's which. Usually, the hypotenuse is called C. And so the sum of the squares means add them together. If you square one leg and add to the square of the other leg, that's always going to come out to equal the square of the hypotenuse. It works every single time. And so we could use this to solve or to figure out if one of the sides is missing. We could use what's known as the Pythagorean theorem to find the third side. Quick example of that. If I had a triangle that looked like this, and I called this as missing, and I said this number, I'm just going to pick a random number. This number is 9. This number is 5. Then I would say, well, x squared plus 5 squared is equal to 9 squared. X squared plus 25 is equal to 81. Subtract 25, I get x squared is equal to, let's see, if I subtract 5, it's 76. If I take 20 away from that, then we're at 56. Then we're at 56. Now we square root it. And this is why we had to practice what to do with all those square roots and stuff like that. X is going to equal, is there a perfect square that goes into 56? Well, I know 4 times 15 is 60, like on a clock. 4 times 15 is 60. So this must be equal to 4 times 14. And 14 can be split into 2 times 7, but neither one of those has a square root. 4 does. So the answer is 2 root 14. That's the exact answer, not a decimal answer. That's the answer you're going to write down, simplest radical form. Now notice I didn't put plus or minus here because we are talking about the side of a triangle. The side can't be negative, so you just sort of ignore the negative answer. Just sort of throw that away as extraneous. So that's a real quick example of how to use the Pythagorean theorem. There's something called the converse. The converse of the Pythagorean theorem. What is the converse of the Pythagorean theorem? All right, converse of the Pythagorean theorem. This would be, you don't know it's a right triangle. That's what makes the converse, okay? What you do know are the sides. If, let's see, if the sum of the squares of two sides of a triangle is equal to the square of the third side, then you know it's a right triangle. Okay, now that may not seem like, oh, it's not really that big of a deal. Mr. B, you said up here, in any right triangle, a squared plus b squared equals c squared. Down here, what they're saying is, hey, you don't know it's a right triangle. I'm going to give you three numbers. And then you sort of go to yourself, you say, all right, I'm going to take this number squared plus this number squared. Does it equal the square of the third number? Remember, in any right triangle, the biggest number has to be the hypotenuse. So out of the three numbers, your c would have to be the biggest number that is shown. So we know that if a squared plus b squared equals c squared, then it's a right triangle. All right, nothing really huge from what we learned up above. However, there is more to it. If it doesn't come out equal, if a squared plus b squared, if that part ends up being smaller than c squared, all right, so the biggest number you squared, it's actually bigger than those two squared put together, then it's an obtuse triangle. So they're going to ask you, hey, try it out. If it comes out equal, it's a right triangle. If it comes out where the a squared plus b squared is smaller than the c squared, then you have an obtuse triangle. Or if it comes out the other way, where the leg squared is bigger than the c squared, the hypotenuse squared, well, it wouldn't be a hypotenuse then it's an acute triangle. Then it's an acute triangle. An acute triangle has all three acute angles. All three angles are acute. All right, so keep that in mind. So that's what's known as the converse of the Pythagorean theorem. These three little rules are going to be very important to you. So the Pythagorean theorem is probably going to be more important, but that and this are going to be pretty big test questions and work that we have ahead. Speaking of work, well, I'll save my examples for right now. Let me do one more thing. I'm going to teach the distance formula. I'm going to throw that in before I do examples of all this stuff. So this is from section 9.5, but the distance formula. So how do you find the distance between 2 points? The distance formula. So this is like on an XY coordinate grid. This is Y, this is X. And I give you a point here, let's say it's A. Point here, let's say it's B. We draw a segment in between. Oop, I'm kind of missing it. Draw a segment in between, and we say, hey, what's the length? What's the distance between those 2 points? What you need are the coordinates. So let's say this first one is called XY, but we'll call it X1 and Y1. And the second one, we'll call it the second X, second Y. So X2, Y2. That doesn't mean squared. I'm just naming, that's the first X and Y, that's the second X and Y. To find the length of this, we're actually going to use the Pythagorean theorem. If it went down and it went over, this point here would have that X, X1, and it would have that Y, Y2. And so this length is Y2 going across. So from X1 to X2, if I took this number minus that number, that would be here. And for the Y's, this is as high as Y1, and way down here is Y2. This is a bigger number. If I subtract this from this, I'll have this number. That's where the distance formula comes from. You don't really need this whole diagram. If they want to know what is the length of A to B, it is built off the Pythagorean theorem, but the distance formula is subtract the two x's. All right, doesn't matter which one's first, but I'll do it the way it was on. So it really doesn't matter which one's first. So x1 minus x2 and square it, that's one leg. And then y1 minus y2 and square it. That's what the whole distance formula is. So as an example, and you can make this up with any point that you want, really. Find the distance between, we'll call it C and D, if C is at, let's pick something in the second quadrant. So I'm going to go -5, +3. And D is at, and I'll pick something in the fourth quadrant. I'll go 10, -2. Okay, we're going to use the distance formula. So the distance between those 2 points, all right, to find the length of CD. If they don't put any symbol on top, it means length. To find the distance between those 2 points, you're going to take one giant square root. You're going to subtract the two x's. So I'm going to go -5 minus 10. I could do it the other way around. I could do 10 minus -5. One will give me -15. The other one will give me 15. But when I square it, they'll be the same. And then I'll go 3 minus a -2. So it's like a +2 in there. Square it. So -5 minus 10, that's a -15. And when I square that, that's 225 positive. When I take 3 minus a -2, that really becomes 3 plus 2, so that's going to be a 5. And I square it, I get 25. Oh, look at that. It's going to come out kind of nice. 225 plus 25 gives me 250. And I got to simplify. So sometimes they say, hey, round to the nearest tenth, use your calculator, get a decimal. But this one, we'll put it in simplest radical form. Think of it as 25 times 10. 25 times 10. And that becomes 5 square root of 10. So the length of CD is 5 square root, 5 square root of 10. 5 square root of 10. Okay. As a decimal, I don't have my calculator with me. As a decimal, I don't think I could do this. I don't have a calculator with me as I'm filming. Sorry, I left it in my bag upstairs. So 5 square root of 10, if I want, I can make it a decimal. So you can do the square root of 25, or you can literally plug in 5 root 10 and come up with a decimal answer if you want to do it differently. I am going to do more examples of the Pythagorean theorem. Click over to video number 2 to catch the examples that go with this lesson.